Hello everyone and welcome to Pre-Calculus / Trigonometry, Lesson 6. Today we're going to be talking about graphing trig functions. Now, from my own experience, I used to tutor kids from a high school in New Jersey called Cherry Hill East. Many of you probably go there. Basically, when I was tutoring this class for Pre-Calc, this was like the number one thing that we spent time on. Like, I'm pretty sure we spent like 2 months on this with my students, which is crazy because you shouldn't spend 2 months on anything in math. But it really did feel like a long time with this stuff. And it's right at the end of the year too. So it's probably when your energy's down at your lowest and you really don't feel like learning. So let me help you out and give you all the information you're going to need when you get here in the later portion of the year for next year. So first, I want to introduce the concept of degrees versus radians because we all know what degrees are. And maybe you have heard of radians before. I'm actually not sure. But I'm going to tell you this. I'm going to take away the mystery. I'm going to explain what it is. And hopefully by the end of today, you're going to be able to use it yourself. So my first question for you is, why do circles have 360 degrees? And what I mean by that is 360 is an arbitrary number. It's probably something from the Babylonians because they used a number system based off 60. But honestly, 360 is just a random number. It could be 1,000. It could be 100. 360 is a random number. Which is why when we say, for instance, there's 360 degrees in a circle, and here's a circle right here. You got 0 degrees, 90 degrees, 180 degrees. Down here is 270 degrees. And then ultimately coming back up to 360 degrees for one full circle. It doesn't really mean anything in terms of math. And so what I would say is that we need something that is more concrete, more not made up. And to answer that question, we have the radian or radians. So just to understand what a radian is, radians are actually pretty simple to understand. It's just, the definition is, it's a measurement using the radius of a circle. Measurement using the radius of a circle. And you may be wondering, what does that mean? Well, basically, all circles have something in common. In other words, if you were to take the radius of this circle or a bigger circle or a smaller circle, it doesn't matter. The radius is going to help us define the circumference or the arc length of any circle out there. As a matter of fact, you know this because the equation for circumference equals 2 pi r, right? Well, you probably don't remember. Maybe you do. A lot of my students, if they're in college, they do not remember this, but my high schoolers actually sometimes remember this equation. Circumference equals 2 pi r. In other words, if you want to know how much stuff is in the outside of your circle, you just take your radius and multiply it by 2 pi. And if you were to cut it up into fractions of that 0 to 2 pi, so basically let me say it this way. If this is 0 radians and this is also 2 pi radians when you go all the way around, just like you have 0 and 360, might I add, then you can basically slice this up into different parts. Like for instance, you cut 2 pi in half, you get this guy over here, which is just pi radians. You cut pi in half, and you get up at the top pi divided by 2 radians. It's the exact same thing with 360 divided by 2 is 180, and 180 divided by 2 is 90. And then if you want to know what this bottom one is, it ends up being 3 pi divided by 2. And there, now we have all of the same angles, except not in arbitrary numbers, which is what degrees is. Degrees is just an arbitrary number. Radians are actually concrete, and it's going to be true for any circle out there that you'll ever see. So let's talk about how you can convert between radians and degrees because that's a very helpful skill to know. So here's the formulas that I'm going to give you and I recommend memorizing. If you have degrees and you want to solve for radians, then the number of radians is going to equal your degree measurement, and then you multiply by numerator pi radians, denominator 180 degrees. That's how you get to radians if I give you degrees. And then if you want the opposite, in other words, you have radians and you want to get to degrees, well then the equation is simply degrees equals the number of radians I gave you, and then you multiply that by the opposite. Numerator 180 degrees, denominator pi radians. So I'd recommend memorizing that. We're going to be using it a lot today. And by the way, technically you don't have to do pi and 180. Like for instance, if you want to do pi over 360, 2 pi over 360, or you want to do 360 over 2 pi for the other one, that's the exact same thing. It doesn't matter. Pi over 180 is just a more simplified way of writing it. So, are there any questions on this first page? Okay, great. So then for the first few problems we have here, we're actually going to be converting from radians to degrees and vice versa. And I'm not letting you use a calculator for this, so I'm just going to basically say we're going to try and do this and simplify as much as we can. So here's what I'm going to say. For 120 degrees, it's going to be pi radians divided by 180 degrees. That's the conversion we do. And then we have to ask ourselves, well, how does this reduce? So, for instance, 120 divided by 180 times pi. Well, both of these are divisible by 60. So, like, for instance, 120 reduces to 2 and 180 reduces to 3 if you divide both of those by 60. And if you don't like that method, you can keep dividing by 2 or dividing by 3 or dividing by 6 until you get down to what I have here. Basically, the final answer is 2/3 pi. So that's it for that first one. Now for number 2, we have 60 degrees. So for 60 degrees, it's going to be times pi radians over 180 degrees again. And you're going to notice it's something very similar. What's going to be is 60 divided by 180 times pi. Again, both of these are divisible by 60. So the numerator will just become 1. The denominator becomes 3. It looks like our answer is 1/3 pi. And there's the answer for number 2. Now for number 3, it's the opposite. I'm giving you radians, and we got to go 2 degrees. So for that, here's what I'm going to do. I'm going to start with pi. I'm going to multiply by numerator, 180 degrees, denominator, pi. You notice the pi's cancel, and you just get 180. And 180 degrees is the final answer for that. Any questions on any of these first 3? Okay, then next. Number 4, pi over 6 radians. So it's a similar idea. We start with pi over 6. You're going to multiply by numerator, 180 degrees, denominator, pi. Once again, the pi's cancel, and we get 180 divided by 6. Each of these is reducible by 6, so like the denominator just becomes 1, and the numerator, 180 over 6, that's going to be 30. And so what we're going to get is 30 degrees. By the way, all the angles we've looked at so far, 120 degrees, 60 degrees, pi radians, pi over 6 radians. Well, actually, number 5 is different, but number 6, basically, all the examples except for number 5, because I messed up on number 5, are all examples we talked about last time in terms of those angles you need to know. Like 30, 120, 60, 180 degrees. But now we're going to learn that we also need to learn and memorize all of these angles all over again, except with radians. Now today I'm not going to quiz you on sine, cosine, and tangent values like I did last week, but I will tell you we are going to be graphing the sine and cosine functions, which is like a completely new skill set. In other words, even if you were terrible at the stuff last week with memorizing sine, cosine, tangent, it doesn't matter. You have a whole new list of stuff that you can be terrible at this week, so that's very exciting for you guys. Anyways, number 5, 200. Again, I'm going to multiply by pi over 180. 200 divided by 180 times pi. Both of those are divisible by 20. Like, for instance, 180 over 20 is 9, and 200 divided by 20 is 10. So it looks like 10 over 9 pi. That's my final answer in radians. And then for the very last one, we have 2 pi over 3. Same idea as before. You're going to multiply by numerator, 180 degrees, denominator, pi radians. The pi's cancel, and you're going to get 2/3 times 180, which I'm just going to tell you is 120 degrees. And you can get that using the same simplification techniques we were using earlier. Now for the rest of the lesson, I'm assuming you're not going to be super comfortable with this pi stuff and the radians yet, but that's not the point. The point is that what we're going to be doing next is the focus of today. It's graphing sine and cosine. It is an extremely difficult topic the first time around, and I expect you to have a lot of trouble. But I also expect me to be a good enough teacher where it's going to make sense enough to answer the questions in front of us, and that's all I care about for today. I don't expect you to be experts. Now, how to graph sine and cosine. So if we just remember what sine and cosine are, sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. What I also want you to remember is that sine typically looks at the y values. Let me explain. Sine has the opposite leg, right? That's this leg right here. Well, that's the y values. And then x has the adjacent leg, which is that leg right there. That's going to be the x values. And so just imagine as you go around this unit circle here, and you get to like any point on the unit circle. Like for instance, this point right here, this point right here has a y value that's positive and an x value that's negative. And so we expect it to go kind of back and forth as we take our angles and triangles really all the way around the circle until we finally get back to the beginning again, where it's just going to repeat over and over and over again forever. So here's what I need you to remember. Not even so much this stuff that sine is the y values and cosine is the x values. All of that's important, of course. But what's most important is what's coming up right now. Here is a list, a table of values. I know it's kind of small. I apologize. But I'm going to help read it to you so it won't be too bad. And you'll notice I gave all the angles here in radians because that's going to be our new favorite units we're going to like to use. Now, just for today, since I'm feeling generous, I will, right above here, I will write the number in degrees so you can at least understand it. Like, for instance, this is 0 degrees. Pi over 6 happens to be 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. Pi over 2 is 90 degrees. Pi is 180 degrees. 3 pi over 2 is 270 degrees. And 2 pi is 360 degrees. I'm going to give you a second to write that. But just remember, it's all the same numbers we were looking at last time, at least for degrees. So now, beneath that, I'm going to write the value in terms of sine x. And maybe you remember this from last week, but regardless, I'm just going to be filling in this table because that's not the important part for today. The important part is graphing it. Sine of 0 is 0. Pi over 6 gets you 1/2. Pi over 4 gets you root 2 over 2. Pi over 3 is root 3 over 2. That's a fun one. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is back to 0. And because we're going to be graphing this, and no one knows what root 2 over 2 is, or root 3 over 2 is, as a decimal, I'm going to tell you the decimals for these guys. Like, for instance, 1/2 is 0.5. Root 2 over 2 is 0.71, and root 3 over 2 is 0.87. So now let's graph this. I have this beautiful graph right below where we're going to graph the sine of x, at least for the first, we call it a cycle, and you'll see why we call it a cycle. And you know how we graph things, xy coordinate points. So the first coordinate point is 0, 0. That's right here. The next point is 1/2, 0.5. That will be about right there. I forgot to label the y values. That's positive 1. That's negative 1. Now for the next point, x is pi over 4. You know what's funny? I'm off. That's not 1/2. That's got to be pi over 6. Pi over 6 is actually shifted to the left a little bit. I apologize. It's right about there. That's where that point should be. You don't have to be exact. Don't worry. We're also not going to be doing this for most of today, and you'll see why. The next point, pi over 4, 0.71, is kind of like up here. Then pi over 3, root 3 over 2, that's going to be like this point right here. And finally, we get to pi over 2, 1, that's this point right there. And so at least if I were to graph this first portion, if I were to connect the dots, it's going to look like this. It's going to be a little bit curved, and it's going to I guess you would say, plateau at 1. Like, it's not going to get any higher than 1. We've reached the peak. Now, the next point I have is after pi over 2, it looks like I have pi 0. We go down here. And I'm just going to tell you the graph is going to look basically the exact same shape except mirror opposite on that side. And we know that because when we were doing the unit circle last week, we saw how many mirror opposites symmetry there was in sine and cosine with pi over 3, pi over 6, pi over 4. Hopefully you remember that. If not, I don't really care. It doesn't matter today. Next, 3 pi over 2, we get down to -1. That's that point right there. Again, follows the same curvy shape as before. And then finally at 2 pi, we get back to 0, so we end right there, approximately. So this is what the sine graph looks like, at least for the first cycle, we call it. This is from 0 to 2 pi. And next we're going to do cosine, and we're going to see how it's different or similar. So I'm not even going to bother drawing the angles above it. It's the exact same angles as before. I'm just going to tell you the values. The cosine of 0 is 1. The cosine of pi over 6 is root 3 over 2. The cosine of pi over 4 is root 2 over 2. The cosine of pi over 3 is 1/2. The cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And then the last one, cosine of 2 pi, we get back to 1. And then again, if I were to graph these points using the same strategy I did before, and honestly, I'm gonna skip pi over 6, pi over 4, and pi over 3 because I don't actually need them. We get 0, 1. Next is pi over 2, 0. Next is pi, -1. That's down here because remember this is +1. That's -1. 3 pi over 2, 0, and 2 pi, 1 back up here. So what I want you guys to know, I want you to know that basically it's the exact same shape. And again, you got to make it curvy. In other words, if you write this, don't write this, don't copy this. This is wrong. It's not a V shape. It is curvy. And it is not curvy like this. Some people do this, and I don't know what they do after that. This is wrong because it doesn't look like, well, I don't know how else to say this, but it literally looks like if you were on a roller coaster here and you were going to pi, you are going to get crushed and die if you're at pi. So basically, when you're drawing your sine and cosine curves, it needs to look like a roller coaster where you're not going to die when you're on it, for lack of a better term. I mean, just look at my sine curve here. The sine curve, if this is a roller coaster, I mean, maybe you hate roller coasters like me, but at least you'll live. So that's an advantage. Same idea with this cosine one. It's going to just have this hilly shape that goes the other way, like that. So now, one last thing I want to say before we move on is that this sine and cosine curve technically goes on forever. As you can see, I only included on my graph 0 to 2 pi for both of these. But technically, it keeps going on. It's going to keep following the same shape in both directions, including the negative direction. And the same is true for the sine. The sine keeps going as well. So that's a very important thing to note for the sine and the cosine graphs. Now, before we go on, are there any questions? Okay, so I do want to mention one more thing before we move on, and that is the fact that we really, if you want to know how to graph sine and cosine, and I'll be covering that on the next page as well, but one thing I just want you to notice is that with all of these graphs, I guess sine and cosine, is that you only need 4 tick marks to graph the entire thing. I guess technically 5 tick marks if you count 0. Let me explain. You need this point, 2, 3, 4, 5 tick marks. But again, if you're counting 0, it's 5 tick marks. If you just go 4 tick marks to the right, you get back to where you started. See how with the sine graph, 5 red tick marks, really 4 to the right, you get back to where you started. Same with cosine, 1, 2, 3, 4, 5. We're back where we started. We're at the top. So in other words, when I start graphing these, and I start graphing them myself, and you're going to be graphing these too today on your own, hopefully. We're going to see how that goes. But when you're graphing these on your own, just remember, you need to go 4 tick marks to the right, or you could even do 4 tick marks to the left, or 4 tick marks in a combination of directions. I don't really care. But you got to go 4 tick marks to the left or the right. I'm going to be doing the right because it's just easier. It's positive. So anyways, let's talk about, this is going to be the hardest part of today, and one of the hardest things in pre-calc. So I hope you're ready. we have this crazy function here that is basically the worst case scenario for your sine and cosine graph. Now, each of these letters, A, B, C, and D, makes the graph change. It can either make it taller or shorter. It can make it stretched out or longer. It can move it up, down, left, or right, like a shift, up, down, left, or right. Now, let's talk about what this is going to look like. So first, A, that's this A right here. A is called the amplitude, and it describes how wavy the function is. That's not a very good description, I'll admit. A better description would be to say how high/low it goes. And we'll be talking about how to find that, but it's how high or how low you go. Now, next, B. This B right here, which is in front of this second set of parentheses, is called, well, I guess it's called a wave number. It really is used to find the period. Now, what the heck is period? The period is the time it takes to complete one cycle, one revolution. So going back up to this example, I would say the cycle for both of these, the period for both the sine and the cosine in this last example here was 2 pi for both. Why is that? Because you can see the period is the time it takes to get back to where you started, complete one lap. Now, what does it have to do with B? Well, B has an equation to find the period. B is equal to 2 pi divided by the period. Now, you'll see in my notes that I call the period 2 pi over t, where t is the period. Yeah, why do I do that? Why am I so mean? Because typically, for these sine and cosine graphs, typically the x-axis is time, and the t stands for a time. And it also stands for period, which I'll admit is kind of confusing, but it's the same thing. Time is period, and it's one lap. So we'll look at some examples on how to do that. C is the horizontal shift. You'll notice the minus sign here means it's the opposite of whatever C is. So in other words, if I have x plus 2 here, that means C is actually negative 2 in that example. It's always the opposite. Very similar to vertex form of a parabola. If you don't know what I'm talking about, Google vertex form of a parabola and you'll see what I mean as far as this equation goes. And then last is the vertical shift. That's what D is. Luckily for D, it's not the opposite. If that's plus 2 at the end, then D is just plus 2. That's pretty easy. And then the last thing we need to know here before we start graphing is that these 4 functions are basically, you can call them families. Let me explain. This is the graph of sine x. The top left one is sine x. Notice what's very famous about sine x is that it starts in the middle. It starts in the middle position and goes up. It starts in the middle and goes up. That is what sine is famous for. Cosine, on the other hand, cosine is famous for starting at the top. Cosine will always start at the top, and once you start at the top, you don't go any higher, you're going to go down. So that's what cosine does. The next one, bottom left, looks very similar to the sine above, except it goes down. Yeah, that's because this is negative sine x. Let me draw that better. This is negative sine x, and negative sine x is going to start in the middle and goes down. It starts in the middle and goes down. That's what negative sine does. And then the last one we have, of course, has to be negative cosine x. And this one's famous because it starts at the bottom. So negative cosine x is going to start at the bottom. Positive cosine x starts at the top. And both sine and negative cosine always start at the middle. And I would highly recommend memorizing these 4 forms, because later today when I ask you to come up with the graphs, after I give you the graphs, you're going to have to know what these 4 look like. But don't worry, I'll remind you, at least for while I'm with you. Okay, now we're going to talk about how to graph sine and cosine functions. The first thing you need to do is you need to find the starting point, and we're talking about sine, cosine, negative sine, or negative cosine. After you identify the family, I kind of have this out of order, I'll admit. I put just the starting point, horizontal and vertical shift. That's not, as it turns out, the best idea. I tried it earlier. It wasn't the best. I'm actually going to put this in like right here after step 4. And you'll see why later on when I explain it. The next thing you want to do, actually, really step 2, is find the period and plot it. Remember what we said about period? Period is where you go back to the start. So in other words, if I have the cosine graph and I want to plot a period, and I know cosine starts at the top, then I know one period later, whatever that is, let's just say 2 pi as an example, then I'm going to be at the top again, and every point in between is going to go to the bottom, or at least middle, bottom, whatever. After I plot the period, and technically I didn't actually want to plot this line yet, I just wanted to plot the period, I'm going to cut the graph in half twice. Now, the reason I cut in half is because, like I said before, I need 4 tick marks, and you're going to notice 4 tick marks, and this cut in half strategy that I'm going to use are going to work perfectly together, as you will soon see. Then I'm going to adjust the starting point for horizontal and vertical shift, and then I'm going to draw the graph by connecting the dots. Now, that's very nice said in theory. I'm sure you're all excited to try it out. But let's actually do an example, and you'll see how hard this really is, or easy if you think this is easy. For the following examples, or problems, state the amplitude, period, vertical shift, and horizontal shift, and then plot the function on the graph. Now, I'm okay if you don't call it amplitude, or period, or vertical shift, or horizontal shift. Instead, if you just want to call them A, B, C, and D, I'm okay with that too. I'm pretty sure your teachers will as well, because they know what you're talking about. Like, for instance, let me just remind us that the form is y equals A times sine of B times the quantity x minus C, close parenthesis, plus D. That's the form that we're going to be writing in today. And of course, this works for sine or cosine, or negative sine or negative cosine. So with this first one here, I would say that it looks like 2 is equal to A. A equals 2. And remember, A is the amplitude. A is the amplitude. That's how high we're going to go. Next, if you only see an x here, that's great news for us, because it means that both B, well, I guess B isn't 0, because that would mean it's nothing, but B is 1, okay, because there's an invisible 1 in front of that x, and C is 0. And I know that because it's just x in that function. And then finally, D is the thing that goes after it. D is just going to be negative 1. And another thing to know about D, I'll just show you right now. D is important because this is, I call it the midline. The midline is where the sine and cosine graph is all going to go up and down around this point. So for instance, if I say this is negative 1 down here, I'm just going to draw a dotted line all across negative 1 because I know it's going to look something like this, where it's going to go up and down around that line. Now, don't actually draw that line, that squiggly line. I'm just giving an example. But you're going to notice everything is going on around negative 1. That's how we account for D. So we found the amplitude. We found the vertical shift. Vertical shift is the same thing as a midline, by the way. That's okay. Horizontal shift is 0. That means we're not going left or right. The only thing left to find is the period. And remember, period, I don't think I give this equation. I gave another equation, but this one works too. Period equals 2 pi divided by B. This is something I'd recommend memorizing because it's always true. And in this case, B is 1, so it looks like the period is 2 pi divided by 1, which is just 2 pi. Now back to what I was saying about how we graph these things. First thing you want to do is, where is your period? Your period's at 2 pi? Okay, well then I'm going to count 4 tick marks to the right, because that was the magic number I said earlier, 4 tick marks to the right. 1, 2, 3, 4. Of course, starting from 0, count 4 tick marks to the right. 1, 2, 3, 4. This point right here is going to be 2 pi, I promise you. I don't know where my actual sine or cosine curve will lie, but I know that in terms of making my own axes, because we're going to have to build our own axes today, and that's okay. Oh, and by the way, when you're actually doing this on your own, a lot of times they're going to give you the axes. You don't have to do what I'm doing right now. But I think it's actually easier if you build it yourself the first few times, and then you're going to be real experts at this at some point in the future. Anyways, the period is 2 pi. If you remember what I said next is the cut in half strategy. So if this was 4 tick marks to the right, cutting it in half will only be 2 tick marks, right? 4 cut in half is 2. So 2 tick marks to the right is just going to be pi. Why? Because 2 pi divided by 2 is obviously pi. Now that was a cut in half once. We got to cut in half again. So instead of 2 tick marks to the right, I'm going 1 tick mark to the right. And what's pi cut in half? Well, it's going to be pi over 2, of course. So the reason why this cut in half strategy works so well is because now there's no more guessing games in terms of what my x-axis is going to be. I've got it right in front of me. Pi over 2, pi. You may notice I'm missing 1 point. That's easy to find. The reason why is because you just keep counting by 1. Let me explain what I mean. The first point is pi over 2. The second point is 2 pi over 2. The reason why I didn't write 2 pi over 2 is because 2 pi over 2, of course, is pi. It reduces. That means the next point's going to be 3 pi over 2, and the last point is going to be 4 pi over 2, and that reduces to 2 pi. In other words, the only one that's missing is this 3 pi over 2 here, and that does not reduce. So what I'm saying is if you want to find all the ones that come after this, all the x values that come after this, you just keep having to count by 1. In other words, you'll see 2 more tick marks. Those are kind of optional, but I know what they are already. It's 5 pi over 2 and 6 pi over 2. And I know 5 pi over 2 does not reduce, so I'll just leave it like that. And 6 pi over 2 will reduce to 3 pi. So there we go. I've got all of my x-axis figured out now. I'm going to erase my red ones because I'm going to need more room. I guarantee it. But that's it. We've done now the period. We've done the divide and cut in half by 2 strategy. And now what we're going to do is we are going to actually plot these points. Oh, I skipped a step. The moving, right? So normally sine, this is sine. Sine starts at middle. And remember, we moved the middle down. We moved it down to here. So in other words, my first point for sine is going to be down here. Does that make sense? Okay, good. So sine starts in the middle. We then have an amplitude of 2. That means, and remember, sine goes up. Okay, so my next point is going to go up 2. 1, 2, and then to the right one. Let me, again, move these values. They're going to get in the way. That's better. So anyways, going up 2, 1, 2. There's my next point right there. And then sine's going to go back down to the midline. Okay. Then we got to go down 2. You may notice I didn't prepare these graphs the best, whatever. Here's -2. Going down another one gets us to -3. That's fine. And the point's going to be all the way over here at 3 pi over 2 in the x and -3 in the y value. Next, at 2 pi, we get back to 0, and then we've completed one cycle, but we can keep going, and the cycle is just going to repeat. And when I say cycle, notice this pattern. Middle, up, middle, down, middle. Middle, up, middle, down, middle. Basically, always go back to the middle and alternate between high and low. That's all you do for sine and cosine. So again, middle, high, middle, low, 0. Next is high. And then, not low, back to middle. Okay? You can never go from high to low. You always have to go to the middle first. And now I just got to connect my lines in this wavy pattern that sine and cosine do. So this is what it's going to look like. There, perfect. And if yours doesn't look like this, it's fine, as long as you imagine that this sine curve is a roller coaster and you don't crush any of the passengers by running into a corner, a 90-degree angle in the track. That's what you got to look out for. So for the rest of the day, we're basically going to be doing examples of this. We have 6 examples coming, I guess another 5 examples coming up. And then after that, we are going to be actually doing something else in the same vein as this. So yeah, we might even go overtime. This is like extremely long, but don't worry. I am going to cover it nonetheless. Next one, y equals the cosine of whatever nonsense is in the middle here. But it's really not nonsense. Why not? Because we know, based on our formula we said earlier, a is the invisible 1 in front of the cosine. B is that 2, which is going to help us find the period. C, remember, it's always the opposite, negative pi over 4. You can remember that as a shift of pi over 4 to the left. That's what that's going to do. And then D is 0, it looks like, because there's nothing going on after. That means there's no vertical shift. Our midline is at 0. That's nice. So amplitude's 1, great. B equals 2. I'm going to use that to find the period real quick. Period equals 2 pi divided by B, which is 2. Looks like the period is pi. I'll plot that in a minute. Then next, I know it's cosine, so I know cosine is going to start at the high position. It's going to start at the high position. And in this case, since the midline is 0 and the amplitude is 1, I know already I'm going to start right there where I plotted that. I'm going to change the color. I'm going to make it a red dot so you can see it. So that's where I'm going to be starting. Okay, next. The next thing I do is I need to plot the period. Remember what that means. It means I'm counting 3 tick marks to the right, and I'm putting pi there. Why pi? Because that was the period right there. So 1, 2, 3. I don't know if I said 3 tick marks. I meant 4 if I said 3. I apologize. 1, 2, 3, 4. There's pi right over there. And then again, I got to cut in half. So the first cut in half, instead of going 4 to the right, I'm only going 2 to the right. So 1, 2. We get pi over 2. Then next, I got to cut in half again. Pi over 2 cut in half is pi over 4. And then after that, if you want to get to this last point that's missing, remember what we said before. It's 1 pi over 4. Then 2 pi over 4. Ah, there it is. The missing one is 3 pi over 4. So there we go. I got all my x-axis figured out. And by the way, in case you're wondering what the left side is, I'll tell you. It's the exact same thing except it's negative. Like negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative 4 pi over 4, which is just negative pi. I'm going to give you a second to copy. I know my handwriting's sloppy. Yeah, that's it. So now we cut in half twice. What's next? Figure out the shift, right? So actually, it's funny. I'm going to have to end up erasing this point anyway because I have to move it pi over 4 to the left. That's what c equals negative pi over 4 means. So moving it to the left pi over 4 means I move it 1 tick mark to the left to right there. So there we go. Now I've got the starting position. I'm going to graph my cosine. I'm going to start here. And remember the order. The order is middle, high, middle, low, middle. Except cosine, you're already at the high position. So you actually go high, middle, low, middle, high. Let me say that again slower. High, middle, low, middle, high. And the reason why I'm only going up and down 1 this time is because my amplitude is 1. And by the way, amplitude is not measured from the top to the bottom. Amplitude is always measured from the middle to the top. Or you could say middle to the bottom. That's the same thing. Anyways, if I continue this pattern from the left and to the right, I got one more point over there, pi 0. Going to the left, it's going to be middle, then low, then back to middle. And by the way, do you have to go more than 1 cycle? I like to go as many tick marks they give me, because that's probably how much they want me to go. So now I just have to connect these points. And I do it in a wavy fashion, just like this. Look how good I am. Yeah, I've been doing this for many, many, many years. So I'm very good at it. You, probably not as good. Probably. And by the way, the reason why I marked this start point is not just for my own sake, because you know as well as I do, I don't need to tell myself where I'm starting. I'm doing it for your sake. If you have in your notes that that was the starting point, it's going to be a lot easier for you to look back at your notes and say, how on earth did I draw this? Because let's just imagine the start is gone for a second. Let me just erase it, okay? Where was the starting point? Like, to me, it just looks like you just connected a bunch of dots, and how'd you know where any of those dots went? It's because we follow a strategy, and we do the same thing every time. That's the secret to this stuff. So that's it for number 2. Any questions? Okay. By the way, we're only going to get better the more practice problems we do. That's why we're just going to keep going. Okay, next, y equals negative sine of 4x. First thing I do, a equals negative 1 this time. Now, one thing I do want to say is amplitude technically cannot be negative. I'm going to say the amplitude is positive 1, even though a is negative 1. And that's okay because it means the same thing. Remember, negative sine is exactly the same thing as sine, except you flip it. It starts in the middle and goes down. Starts in the middle and goes down. We know that b is the thing in front of the x, so b equals 4. And since it looks like there's no c or no d, c equals 0, d equals 0, it means there's going to be no shift this time. That's very nice for us. Next, I'm going to say the period. Period is equal to 2 pi divided by 4. That reduces to pi over 2. And so already, before I graph anything, I already know pi over 2 is 1, 2, 3, 4 tick marks to the right. 1, 2, 3, 4. There's pi over 2 right there. If I want to cut in half again, or at least cut in half for the first time, 2 tick marks to the right, that's pi over 4. And if I want to cut one more to the right, it's pi over 8. And again, that missing one right here, 1 pi over 8, 2 pi over 8, that one's 3 pi over 8. And then if I want to keep going, this is 4 pi over 8, which is pi over 2. Then I've got 5 pi over 8. And then I've got 6 pi over 8, but that just reduces to 3 pi over 4. So I'm going to erase that and write 3 pi over 4 to make it look nicer. Any questions so far? Okay, good. I've cut in half twice. I figured out my period. The next thing I need to do is I need to figure out where does sine start. Well, sine, this is negative sine. So negative sine starts at middle and goes down. Negative sine starts at middle and goes down. Also, since there's no shift, that makes it easy for me. It means I'm going to go here at 0, 0. Then I go down to here. Then I go up to here. That's middle, so I have to go up again. And then back to middle. And then the low position. And then back to middle. And if I graph this, it's going to look something like that. Any questions on that one? So hopefully we're getting better at it. We're certainly going faster, or at least I'm going faster. Next is number 4. Number 4, oh boy. So a equals negative 1 again. And remember what I said before, amplitude is still 1. And it just means I'm following a negative cosine form. Okay. B is pi this time. We'll see that gives some funny results. Next, x minus 1 looks like c equals positive 1. And d is going to equal positive 2. Remember what that d equals 2 means. That means my midline is actually at 2. And I'm going to mark that right there at the beginning so I don't forget it. Okay, next. Period. The period is going to be 2 pi divided by pi. The pi's cancel. Looks like the period is 2. And I'm going to go 4 tick marks to the right and mark it with a 2. 1, 2, 3, 4. That's where 2 is. Then I cut in half twice. So 1, 2 tick marks, that's where 1 is going to be. Cut in half again, you get 1 half. And then as before, 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. But I'm going to erase 6 halves because that's just 3. And that's a poorly drawn 5 right there. That's better. Okay, so we got the cut in half twice. We got our period. Now we have to figure out where cosine's starting. So negative cosine is going to start at the low position. It's going to go at the low position first. And remember, it's at the low position, not down here. Oh no. First of all, you need to shift it up 2, right? So here's really my 0 line. So I got to go down 1 from the midline. So down 1, that point right there. But of course we're not plotting that. Why not? Because C is 1. you need to shift it 1 to the right. You're going to notice shifting 1 to the right is actually 2 tick marks. That's okay. It just means I put my starting point right there. And again, why did I do 2 tick marks to the right? It's because I needed to shift it 1 to the right, not 1 tick mark, but the number 1, and that's where 1 is. Okay, so that is my starting point. Remember, that is the low point. Don't forget, which means that the next point, the next tick mark I do is going to go up, because you can only go one way from bottom. It's going up. So next mid position, then high position, then back to the mid position, then the low position. And then going the other way, you're going to go mid position, then high position. And then literally I am going to connect the dots like that. And there we go. There's our answer. Any questions? Okay. 2 more to go. And then we're going to do something even harder. Well, actually, no. The thing after this is actually easier. But the next 2 problems are the hardest ones coming up. And you'll see why. So first, there is a typo on this. This is not supposed to be 1/2. It's supposed to be 1/2 pi. So it's supposed to be plus 1/2 pi, not just 1/2. Sorry. Anyways, a this time is 1/2. It's a fraction. That's okay. If you want my opinion, you should probably just mark this off as 1/2. And then that's 1, and that's 3/2, and that's 2. For your y-axis, that's just going to make it easier for these tick marks. Now for the b. So the b is 4 pi, but you see how it's missing parentheses? Like before, it would have looked like this. 1/2, parenthesis, 4 pi, parenthesis, x plus 1/2 pi. Like this is what we saw before, but this is not what we have. That second set of parentheses is missing. Is that important? Absolutely. What you need to do right here is you need to divide both by 4 pi. You're not really dividing, you're factoring out of 4 pi. And when you factor out, it's going to look like this. We're factoring out 4 pi, so it's 4 pi times the quantity, x plus, the pi's cancel here, 1/2 divided by 4. Hopefully you know this with fractions. That's going to be 1/8. If you don't know why, it's because it's the same thing as 1/2 times 1/4, and that's 1/8. Okay, so hopefully that makes sense. Anyways, the point I want to make is that notice the difference between what I had originally. Originally it looked like C was going to be negative 1/2 pi, but that was wrong. The correct answer is C equals negative 1/8, and B is still 4 pi. B did not change, C changed. That's why it's important to factor out whenever you're missing that second set of parentheses. You'll notice number 6 is going to have the same problem, basically. Also with cosine, we know cosine starts from the top position. Cosine starts at top. Okay. It looks like D is 0, which means there's no vertical shift. That means that 0 is my reference point. I want to start at the top, but I got to shift 1/8 to the left. How much is 1/8, right? That's why we do the whole period thing, because we don't know how much 1/8 is right now. Could be 1 tick mark, could be 2 tick marks, could be 4 tick marks. I have no idea. So how do we find the period? Well, we know that. Period equals 2 pi over b, and we said b was 4 pi. The pi's cancel. That's 1/2. So the period is 1/2. 3 tick marks to the right. That's 4 tick marks to the right. I keep making that mistake. 1, 2, 3, 4. That's where 1/2 goes for the period. Then I cut in half. 1, 2. That's 1/4. Then I cut in half again. It's going to be 1/8. And then to figure out what the missing one is, 1/8, 2/8, 3/8 is the missing one. And then obviously 4/8 is 1/2. And if you want to go in the reverse direction, it's negative 1/8, negative 1/4, negative 3/8, and negative 1/2, because it's just the mirror opposite of the right side. So it looks like we're good so far. We got the period, we cut in half twice. Did we account for the vertical shift and horizontal shift? Not yet. So if we're going 1/8 to the left and cosine starts from the top position, That means my starting point is going to be right there, because that's the top, and we moved 1/8 to the left. Now, at least going rightward, after the top is the middle, then bottom position, then middle, then top, then middle. And then going the other way, we've got the middle, then bottom, then middle. And one more time, I gotta connect my dots. Just like that. And by the way, if we do go over time today, for those joining live, if you have to go, that's fine. But I'm still recording this whole thing, so you're gonna get the whole lesson, at least on video, VHS tape, whatever you want to call it. Anyways, this is good for number 5. Number 6. Number 6, probably the hardest one. First, A equals -1. It's probably and D equals -1. There's only 2 easy parts to this. It's A and D. D and A are the only easy ones. And I know my midline is down here at -1, so I'm going to mark that right now. There's -1. Okay, next, we saw before that I had to factor out the thing in front. So a lot of people don't like x over 2. I don't either. Let's rewrite this as negative sine of 1/2 x minus pi minus 1. Because that's all x over 2 is. It's 1/2 x. Now I know what to divide when I factor out. I'm factoring out a 1/2, which means I need to divide by 1/2. And that's going to give me negative sine of 1/2 parentheses x minus, what's pi divided by 1/2? Well, remember, pi divided by a fraction is the same thing as multiplying by the reciprocal. So it's really times 2 over 1. So it's really minus 2 pi. Close parenthesis, minus 1. So now I've got everything. A is -1, D is -1, B is 1/2, and C is positive 2 pi. Because remember, positive 2 pi because it's the opposite of whatever it's given to you. So now I'm going to try and find my period. Period's not 1/2, remember. To find the period equals 2 pi over B, so divided by 1/2. Remember, dividing by a fraction is the same thing as multiplying by the reciprocal. Looks like the period's 4 pi this time. And that's where I'm going to put it. 4 tick marks to the right. 1, 2, 3, 4. That's where the 4 pi is going. Then I need to cut in half twice. So 1, 2 tick marks to the right. That's 2 pi. And then another tick mark to the right. That's pi. And then the missing one, this is probably the easiest one today. Pi, 2 pi, 3 pi, 4 pi. Then you got 5 pi. Then you got 6 pi. Yeah, this one's fun. I like this one. And then finally, we just have to say, where does negative sine start? So negative sine is going to start at the middle and go down. It's going to start at the middle and go down. And we're shifting it down 1, so following the midline, and 2 pi to the right. So really my starting point is right there. There's my starting point. And then remember, we're going to go down, because that's what negative sine does. It goes down, then middle, then up, then middle. And then going the other way, it's going to go up, and then back to middle. And now I just got to connect my dots like that. Any questions on any of those? Okay, and then for the last part of tonight, we are just going to be doing basically the opposite. I give you the graph, and you just tell me what the graph is. So here's what we're going to do. We're going to need 4 things, just like we did before. We need A, B, C, and D. Here's how we find each. First for A. A is the amplitude, measured from the middle to the top. Looks like my amplitude is going to be 1. That means A equals 1. The next thing I need to find is B, the period. Well, it's related to the period, at least. So hopefully you realize period is the distance from one point to the same point. You can also say it's 4 tick marks to the right, because that's certainly true in this example. Although technically it's not always true. It's not always 4 tick marks. It's only 4 tick marks when the problem gives you 4 tick marks. I was so generous as to do that. Not all problems are that nice. Anyways, it looks like not the b, but the period is 2 pi, and we can use that to find b, because b is equal to 2 pi over the period. That was the equation we said earlier today. It's the opposite of period equals 2 pi over b. So anyways, b equals 2 pi divided by 2 pi. Looks like b is just 1. Now, c is going to be a horizontal shift. You'll notice we're starting at 0 and sine starts at 0. So there is no horizontal shift. And I'm just going to tell you a horizontal shift in this problem would just be too hard. So don't worry about horizontal shifts for these problems for the rest of tonight or on the homework for problems that look like this, because that would just be too hard. And then for the vertical shift, it also looks like there's no vertical shift here because I'm not moving the midline up or down. It's still at 0. So in other words, it follows the formula y equals a sine of b times x minus c plus d. And if I fill in what I have here, it's going to be y equals 1 times the sine of 1 times x minus 0 plus 0. And this can really just be reduced, ignoring all the 1s and all the zeros, y equals the sine of x. In other words, this is just the normal sine graph. That was fun. Hopefully you had as much fun as me. Anyways, next we just got, I think, 3 more problems to go. We're almost done. Number 8. Same thing, except this time we want the cosine form. Before we even go about finding the amplitude, you need to realize that the 0 point is not 0 anymore. Clearly it looks like it's shifted up. Probably the midline is at 1. It looks like it's at positive 1 to me. But there's got to be a formula to find the midline, and there is. If you want to find the midline, and remember the midline is d, so d equals the midline, and that equals the formula high plus low divided by 2. So the high is 3, the low is negative 1, because, just look at the negative 1, that's the low point, divided by 2. 3 plus negative 1 is 2, 2 over 2 equals 1, d is 1. That's where my midline is. I'll put a dashed line there. Now, I can measure the amplitude, because amplitude is measured from the midline to the top. So amplitude A is 2. Next, the period. Period is the distance from, it's not always 4 tick marks. In this case, it is not 4 tick marks. It's the distance from one peak to another peak. In other words, the same point. It looks like to me that the period is 2 pi over 3 because that's when we get back up to the top. And then B is equal to 2 pi divided by 2 pi over 3. Remember, dividing by a fraction, that's the same thing as multiplying by the reciprocal. So it's really this. The 2 pi's cancel, and it looks like B is equal to 3. So I have A, I have B, I have D is 1, and C. Now C, again, I said there's going to be no horizontal shift. You can see that here because cosine's supposed to start at the top, and we do start at the top. So we're good. There's no horizontal shift because we're already starting at the top. That means filling in my formula, y equals A is 2 times the sine, sorry, not sine, cosine. Cosine of 3x, and since C is 0, I'll just ignore it. And then D is plus 1. So there we go. There's the cosine form. And now, finally, yeah, that's it. Yeah, we're done that one. Okay, great. 2 more to go. Number 9, again, another cosine form. First thing we're going to do, I see the midline is clearly at 0 this time, so D equals 0. That also means I can find the amplitude pretty easily. Looks like the amplitude is 5. A equals 5. B is the distance from one peak to another, or the same point in a sine or cosine wave. So it looks like my period is going to be whatever this is. Notice the distance, it's not 2, it's not negative 2. The distance is 4. My period is 4 because I started at negative 2 and got to 2. That's 4 apart. And so what that means is B is equal to 2 pi divided by 4. That's going to reduce to pi over 2. b is pi over 2. Now for this one, we've got everything except c, the horizontal shift. I want you to realize there is no real horizontal shift, but I want you to realize we do start at the bottom. And starting at the bottom means we're doing negative cosine here this time. So what that means is putting it all together, y equals negative 5 cosine, because a was 5, times b, which is pi over 2, times x, ignoring the extra parentheses because c is just 0. And then I don't need to write plus 0 at the end because d is 0. It looks like this is it for number 9. And then for the very last one, number 10, sine form. Looks like we've got some fun decimals here, but that's okay. So first thing I'm going to realize, midline is clearly at 2. If you don't trust me, you can say midline equals top 3 plus bottom 1 divided by 2. You are going to get 2 if you do the math. So that means d is equal to 2. So I'll put the dotted line there for the midline. Amplitude is going to be a equals 1. The period this time. So here's what I'd recommend doing. You can technically choose any point you want. I think it's going to be hard to measure here to here because look, it's not on the grid marks. So then what am I going to do? Well, I'll just pick this point right here and this point right here because that's the same point in this sine wave. And it looks like that distance is 1 apart. So the period is 1. Which means when I go to plug in and solve for b, it means that b is going to be 2 pi over 1. So b is 2 pi. Like I said before, c is 0 because I'm not doing horizontal shifts today. It's also 0 because look at that starting point. The starting point starts at the middle and goes down. That is a negative sine form. So in other words, my answer is y equals negative sine. You could say negative 1 sine, amplitude is 1, of 2 pi x, and then d was 2, so plus 2. And there we go. So I know today was probably the hardest day ever. It was definitely the longest. This is the only, out of all these summer courses I've had so far, this is the only one that's actually gone overtime. So I know it's hard. I'll probably make it easier next year. But either way, please do the homework. If you have any questions, let me know. I'll be posting the solutions in a few days. Thank you all for watching. Hope you have a great rest of your night, and bye-bye.